Hi, I'm Kevin. Omar is recording the video, and we're going to demo our final project for CSCE 462. So essentially what we have built is a random number generator, and this allows us to improve how current blockchains work. So right here, you'll see we have the random number generator connected to the A2D converter, and that's being read to the Raspberry Pi. So right here, let's just first focus on this component right here. Whoops. This is basically a non-inverting amplifier that amplifies the noise caused by these resistors. So if I actually just put here, I'll put the multimeter here and measure the voltage across here. So you see that it amplifies the noise, but also amplifies quite a few bias. So you see the bias is actually at 2.8. And this actually gives us pretty poor random numbers. So what we did to combat this issue is we implemented another one of these amplifiers, and if I measure the resistance, the voltage across here, it's also around in that 2.8 range. So they have very similar gain. And then finally what we do is we connect it to a differential amplifier here to amplify the difference, and thus we can remove the bias and keep all the noise. So let me just run the data, or run our program real quick. So if you look at the screen right here, I'm gonna run this program which basically outputs all the data from the A to D. So you see right now, most of the bits are oscillating, probably like up to this bit. Maybe I knocked over some of the resistors. Let me just move it over a little. But yeah, so like most of the bits are oscillating, as you can see. So this is a pretty good random number generator. So I'm gonna stop this now. And now as comparison, if we instead just only used a singular non-inverting amplifier, so I'm gonna attach the output that's reading to just this output. So essentially, if we didn't include the rest of the circuit and only use one non-inverting amplifier, let's see what the output is. So you see very few bits are random. So only maybe like 2 or 3 bits are random. So you see this is the motivation for all our design right here. We're now going to demonstrate the production of random numbers using our program. So I'm going to start our script, and it's going to start spitting out random numbers. And this is just for demonstration purposes, but what we're going to do is we're going to stop it at a certain point and then test the quality of these random numbers through a series of tests. So I think that's good enough. We'll stop it here. Let me copy all these. Oh, I didn't copy everything. Copy everything. Okay. I'm gonna send it to Omar, and he's gonna run the random number tests to make sure that this is high quality random numbers.
Okay, so I've copied them. This is the Python program that we're pretty much running. Essentially, you put in the binary input here on this top row. You want to select all the tests. These are the 16 most common tests used when assessing random inputs for binary. And then we just execute the test, and then it's complete. And as you can see, almost the majority of our output came out random. We just had one non-random case, so this output was actually really good.
We are now going to demonstrate the blockchain portion of our project. So what we do is we utilize the random numbers that we generate, and using that, we can use that as the consensus layer in our blockchain. So what you see here is I've set mining to true, so now it's going to start generating blocks. I'm going to first set the difficulty as 2, just so you guys can see what happens. And if I start the blockchain, you're going to see that the blocks get generated really quickly. So you can see I already generated 11, 12, 13 blocks. And that's because difficulty of 2 means that if it finds 2 zeros in a row, then it will count that as a block. So of course that will generate blocks really quickly. Now we can modulate the difficulty. So if I change it to 5, it will change how quickly blocks get generated. So if I now try this. So now the blocks are going to be generated a lot slower. If I change it to 8, it should be generated even slower. So I'm going to put that at the bottom terminal so you can see a comparison of all the different difficulties. So you see this one generated 3 blocks already. This one's going crazy. So the reason why having different difficulties for blockchains is important is if the number of participants increases, you want the block time to remain about the same. So the difficulty can be easily adjusted such that the block time remains constant. So as you can see in this view, the difference in block production times. Another thing you should notice is that the hash of the previous hash of the current block is equal to the hash of the previous block. And that makes sense because that's how the blockchain guarantees that the previous blocks have not been meddled with. All right, so this wraps up our demonstration of our project. Thank you.